Hello everyone. In this video, we're diving into the concept of virtualization. Virtualization refers to the process of mimicking hardware and software components, including computers, operating systems, storage, and networking within a virtual environment. Traditionally, businesses operate by assigning one machine to each application. For instance, a company may have 3 servers. One server is dedicated to running an email service, utilizing Microsoft Windows as its operating system. Another server hosts a website and operates on Linux. The last server manages a database using Unix. Thus, each machine corresponds to a specific application and runs a distinct operating system. Now, consider if a single server could efficiently handle all the tasks normally spread across 3 servers. Essentially, this means one server could replace the 3, facilitating all applications while supporting various operating systems. This is where virtualization comes into play. It consolidates multiple physical servers, their systems, and applications into a single physical server operating in a virtual environment. Now, this one server runs 3 virtual machines, VMs. It simultaneously manages applications such as email, web services, and databases, which all coexist on one device. Moreover, it seamlessly operates multiple operating systems in parallel, enabled by sophisticated software. Users interacting with the virtual server experience the same functionality as if they were using separate physical servers, often without noticing any difference. The software responsible for enabling this process is called a hypervisor. A hypervisor allows a single machine to run various virtual machines. It allocates resources like storage, RAM, and CPU to ensure these machines function effectively. There are 2 types of hypervisors, Type 1 and Type 2. A Type 1 hypervisor installs on bare metal hardware, meaning no existing operating system or software is present. It operates directly on empty hardware. Conversely, a Type 2 hypervisor runs on top of an existing operating system, like Windows, Mac OS, Linux, or Unix. In this case, the OS sits between the hypervisor and the hardware. Let's explore how to set up a Type 1 hypervisor. We start with a server case and install the necessary hardware components, engaging components like the motherboard, CPUs, RAM, and storage drives. Now, our server hardware is operational. The next move is to install a Type 1 hypervisor, VMware SE is a common choice. This will be positioned directly on our bare metal server, which at this stage, has no operating system installed. Once the hypervisor is in place, we can proceed to create virtual machines. We begin by allocating the server's hardware resources to each VM, deciding on CPU count, RAM, and storage. After allocation, we will install distinct operating systems like Windows, Linux, and Unix in each VM. Subsequently, we load the specific applications that each VM will support, such as email services, web servers, or databases. That's essentially it. These 3 virtual machines function as 3 software-based computers. Each VM operates independently, complete with its operating system, applications, and allocated resources, mirroring standard computers. Type 1 hypervisors are most predominant, especially in enterprise data centers. Notable examples include VMware SE, Citrix Xen Server, and Microsoft Hyper-V. On the other hand, Type 2 hypervisors run atop an existing operating system and often suit personal computers. Users typically utilize Type 2 hypervisors to experiment with new software or test various operating systems. For instance, a Mac might run 2 VMs, one with Microsoft Windows and another with Linux. Examples of Type 2 hypervisors include Oracle VM VirtualBox, Microsoft Virtual PC, and VMware Workstation. So, what advantages does virtualization offer? Firstly, it reduces hardware and electricity costs. Businesses require fewer physical machines, consequently lowering power consumption. Secondly, it conserves floor space. There's no need to accommodate numerous machines, which saves on real estate costs. Another significant advantage is simplified maintenance. Fewer physical machines mean less need for administrators to manage them amidst potential failures or configuration changes. Portability is also a crucial benefit. Virtual machines stored on one physical server can be quickly transferred to another if necessary, providing essential flexibility. Moreover, virtualization maximizes the full computing potential of machines. Modern servers often run below their capacity as applications fail to utilize their full capabilities. Virtualization enables maximized efficiency, pushing machine capacity to the limit. Lastly, in terms of disaster recovery, virtual machines exist as software files which can be backed up and migrated to various physical machines. If one server fails, others can seamlessly take over. Thank you for watching this video on virtualization. Don't forget to subscribe, and I'll catch you in the next video.